5.7, graph linear inequalities in two variables. Example 1, which ordered pair is not a solution of x minus 3y is less than or equal to 6? I have an x value and a y value. We can substitute those in to see if we get a true solution. So x is 0, y is 0. Is that less than or equal to 6? We have 0 minus 0. Is that less than or equal to 6? Which ordered pair is not a solution? This says that 0 is less than or equal to 6. That is true. The next example will be 6 minus 3 times negative 1. We have 6, and then negative 3 times negative 1 is a positive 3. Is that less than or equal to 6? So we have 9 is less than or equal to 6. That's false. 9 is not less than 6. We have 10 minus 3 times 3. Negative 3 times 3 is 9. Is 1 less than or equal to 6? Last one. We have negative 1 minus 3 times 2. Negative 1. Negative 3 times 2 is negative 6. And we have negative 7 is less than or equal to 6. That would also be true. That is the ordered pair that is not a solution. All right, graphing. We now have boundary lines, and so it's a dashed line. You use a dashed line for less than or greater than. You use a solid line for less than or equal to, or greater than and equal to. You guys know how to graph this stuff? What is the y-intercept? What is the slope? The slope is 4. And the y-intercept is negative 3. We start at negative 3, and then we rise and run our slope. Rise 4, 1, 2, 3, 4, and run 1. Now, it says that y is greater than. That's going to be a dotted line. It says that y is greater than the function. Y is greater than the function. That means, where is greater than the function? Is that here, or is it on this side? Where is it greater? That would be on top of the line. So that means that this is where you're going to find an infinite number of solutions that I could use in the inequality. I'm going to choose a point over here to make sure that it works. Let's go with 0, 0. We have y is 0. 4 times 0 minus 3. 0 is greater than negative 3. That's true. Let's choose a point that's not up here. How about down here? Let's choose 2, negative 2. Y is negative 2. And then 4 times 2 minus 3. 4 times 2 is 8. And this says that negative 2 is greater than 5. That's false. When you have an inequality, all of the solutions that are on this side will work. There's an infinite number of solutions that will work for this inequality. That is fully graphed and checked. Okay, here we go. We have standard form. And we know that when it's in standard form, we can use the intercepts to graph. We can let y equal 0, and that will give us the x-intercept. We can let x equal 0, and that'll give us the y-intercept. When y is 0, that means 2 times 0 is 0. That piece goes away. It says 3x is less than or equal to 12. So what's x going to equal? So we have 3x plus 2 times 0 is less than 12. 3x is less than or equal to 12. We know that x is less than or equal to 4. So x is 4. At 4, we have an x-intercept. Do you have to show yourself the algebra, or can you do it without showing algebra? Now when x is 0, cover it up. It says 2y is equal to 12. So y equals 6. 0, 6 is the y-intercept. Now I need to go back to my equation, and it says less than or equal to. And so now we need a solid line. We need to check some points and see, is it going to be on top or bottom? It's not as easy as the last one. When it says the function is greater than 4x minus 3, we could see that would be on top. But here, we just need to check some points. So obviously 0, 0 is a good one to check. And then just in case I make an algebra mistake, I'm checking another point on the other side. Let's go with 5, 1. So we have 3 times 0 plus 2 times 0. Is that less than or equal to 12? 0 plus 0 is 0, and that is less than 12. That's true. We'll just do one more check on the other side for 5, 1. We have 3 times 5 plus 2 times 1. Is that less than or equal to 12? 15 plus 2, and 17 is not less than or equal to 12. So it was false over here and true on this side. That means I will shade that side. All of the coordinates on this side of the line will be a solution for the inequality. Graphing y is greater than or equal to -3 and x is less than -1. What kind of lines are those? You did a project on it, smiley guy or gal. Those are your horizontal and vertical lines. So y is greater than -3. -3, it's crossing the y-axis at -3, and it's a solid line because of the equal sign. Now we need to know, do we shade above or below? Well, let's pick this point down here, 0, -4. All right, so we don't have an x to substitute in for. All we have is a y value. So we're going to substitute in -4 for the y. Is -4 greater than or equal to -3? False. How about we choose 0, 0? Y is 0. So is 0 greater than or equal to -3? That is true. We chose the point 0 and we got a true statement. We chose the point 0, -4 and got a false statement. So we're going to shade up here where we got a true statement. One more. X is less than -1. Vertical line at -1. It crosses the x-axis. And now we just need to see if we're on the left side or the right side. And that should be a dotted line. Let's choose 0, 0. When I substitute in x is 0, we have 0 is less than -1. Is 0 less than -1? Let's choose a point on the other side. Let's choose -2. We're looking at -2, 0. So when I substitute in that x is -2, it says -2 is less than -1. That is a true statement. So we are going to shade on this side. That is where all the solutions are, an infinite number of solutions to the equation.